So last week we went through some Python basics, understanding what Python is, how Python does things differently from other programming languages. Now we're going to get into a little bit more of basics. First thing we'll start today with is data types. There are different types of data types. So as a programming language, Python needs to understand like what you're defining. So if you're defining a variable, so a variable is something where you can store a value and the value changes over time. For instance, here we're saying x is equal to 11. In strongly typed languages, like if you're doing it in C++ or Java, we'll say int I is equal to 10 or int I is equal to 11. But Python is typed, but it understands the type based on how we define it. So in Python, when we say x is equal to 11, this variable x gets assigned the value 11, and then it gets stored. The value of 11 is stored in a memory location allocated to x, like we saw last week. But it understands in itself that it's an int variable. So if we check the type of x, so here there is some types. So if we define x as this, y as 12.28, and then z as -6j, and I as a large integer which is negative, and then if you choose, I'm going to choose Python 3.8, and then if I check what the types of these are, if you see the first one, even though we didn't really say this is an integer and we didn't say this is a float, Python took the first one as an integer and second one as a float. Similarly, the third one as a complex and the last one again as int. So Python understands what we are assigning, and then allocates a type according to that. And each of these types have a memory size allocated to it. So integer has a 4 byte, so it will allocate 4 bytes to this. While for float, it will be different. If it's a character, it will be like 1 byte. If it's complex, it will be different. So it has different memory allocation for it, the size of memory allocated for it, and it has a different class. So each class, if it's an integer, you can do certain things, while if it's a string, you can do certain things, while if it's a float, you can do certain things. So you cannot, like integer class has certain methods defined for it. You can do only those things, but you cannot do other things that a string class has. So that is the differentiator between those. Are you following along till now? Okay, so I'll move on. The next one we are trying to do is a string variable. So if I put in a name, say I put in like Barney Stinson, which is a famous sitcom name that I love, and then I print in the type of name, then it automatically assigns the class string. So even if I have one character, say I just have the character C, and it try to assign it to name, it still has the class string. We don't have a character type and a string type in certain other programming languages if you're coming from that background. I also want to show that it has a huge range of a 4 byte integer would have a huge range. So even a number that is like really long gets stored in the memory as an integer, and when you return it, like we get back the same value. We don't lose any information. So because there is like 4 bytes, so we have a lot of integers that can get accommodated within that 4 bytes. So that is think that is something it will definitely cover a lot of integers. So even large integers, most large integers that we work on would get covered, but doesn't mean every integer would get covered. So there is a limit to it. So 10 power, like 4, like 2 power, there's a power to 2, within which the ranges are going to be bound. So if I'm going to Google and see what are going to be the upper ranges and lower ranges of so upper range of int in Python. So we can see that the maximum range is not restricted with the number of bits and can expand to the limit of available memory. So if we are assigning a much larger memory, if it needs more than 4 bytes of memory, then it will assign more than 4 bytes, and it gets expanded to that. So that's the reason, like unlike other languages, I think we can accommodate even bigger integers. The 4 byte memory range may not apply. So when you assign something like this, that would limit within the 4 byte memory range. So it will only allocate 4 byte memories for x and z, but for y, because it has a much longer integer, Python goes ahead and assigns more memory so that that integer can still be accommodated within y, and it still has the class integer. So that's something that will take care of, like Python will take care of the memory allocation. So we'll also take care of this 35E3, where we also look at like huge floating point numbers, which are like 12 E4, or like if I want to print the value of z, comma y, comma x. I just want to print all those three to see what values it's stored. So if you can see, we stored it as 12E4, which is like 4 zeros after 12, and it's a floating point integer, so it gives a 0.0. And 35E3 is 3 zeros after 35, and then it shows it as a floating point, while negative 87.7 E100 stores it as 8.77 E101. So it still stores it as a floating point integer, but when it displays, because there are 100 zeros, it does not want to put in 877 and 100 zeros, so it uses the E107 E and then 101. 10 power 101 is what this is multiplied by, so it shows that in that notation to us, but it stores all the values in the floated integer. So the next thing is string, right? So when we use a string, we can use double quotes or we can use single quotes. So if you use single quotes versus double quotes, both would have the same effect. So Python still has both of them in the same types, and Python uses both of them. So both of them are class string, and both of them have the exact same value. So when I print them, whether it's double quotes or single quotes, they print out hello in the same way. Um, Here the uppercase and lowercase definitely matters, but what type of quotes you use doesn't matter in Python. Whenever you want to write multiple lines in a string, we use this triple quotes, and we go on until the last line of triple quotes is printed out. So if you want to print this out, even though we used 3 lines to print it, Python stored it out the same way, and we're able to get the um, full string. It's a multi-line string that we're able to get. Um, so there is actually a end of line character here. If I delete this and then I do this again, I remove that end of line character, but there's an end of line character here and there's an end of line character here. So those two get stored in the string, and we get that particular string back. So those are the different types, right? We covered floating points, we covered integers, we covered strings. Now we're going to look at slightly more complex data types, like something like arrays that you would have heard of. A list is something that we use. So let's look at this. Python does not have a character data type. I said that briefly when we covered the string. So the string is the only class that Python has. That's the only data type. So whenever, even if you have one single byte of string, it still is considered as a string. So we spoke about the integer I. Now I'm assigning the value 2. That makes it, if you see, it automatically assigns the value, the class int. Now I'm going to convert that int I. This I is an integer. Now I'm converting that into a float by calling the float method. So float of I, or float brackets I. This, what it does is it converts I into a float type variable. So let me just do this in a way where we do it in 2 steps. Now I'm going to say f is equal to float of I, and then I'm going to print f, and then I'm also going to print type of f, so that we know what type Python has assigned it. So now the value of 2, when I used float of I, it got stored in f, and because it's a floating point integer, Python represents that as 2.0, and the class of that, or the type of that variable, is a float. Here, instead, when I assign 1.1, directly Python knows it's a floating point variable. Now when I try to convert that into integer, it loses the value of 1.1. Say if we do 1.99985, what do you think the variable will be in int of f? So if you see, it's actually lost that variable. It doesn't round this up and say this is actually 2. It just loses everything in the decimal value, and then it throws out the value 1. Now let's try the same number, but I'm giving it in quotes. So Prem, what do you think will be the type here? So I'm giving this 23, but I'm using single quotes here. If I try to print the type of this, what do you think would be the type? Let's try that. Now that we use a single quote, even though it has a number, so Python doesn't look whether it says ABC or 235, 235.12. It still assumes that because it's inside a Yeah, inside a quotes, it assumes it's a string. Yeah, that's it. Now, if I convert this into a integer, this string, so this is actually a string, or let me call it num str so that you understand what it is. If I convert this num str into a string, into an int, so this int function converts this string value into an integer value. So it takes in a string value and then converts it into an integer value. I have not run this, so let me do this. Now that I have defined num string, I'm going to rerun this. Now what happens is invalid literal for int, so it cannot understand what 235.12 is, and it's unable to convert that into an integer. Obviously, when I do this, and then when I convert that into an integer, that's when I get a valid value, that is 235. So this converts this into a integer. Or if I want to do this still with 235.12, I have to convert it into a float. That will give me the value without losing the decimal values. I'm sorry, I didn't run this, so it's not taking the right value. So now when I run this again, it takes the 235.12 and produces that as output. So whenever I use the single quotes, even though it's a number, Python doesn't understand it's a number, so it takes the value inside as the literal string. So it assumes this 235.12 itself is a string because it's inside the quotes. Now this is a long string, so when I type it out, as we expect, Python assigns the class string for it. Now let's look into other type of data types, which is like Boolean. A Boolean type can take values true or false. Here I'm taking this one condition 1 as a variable and assigning true to it, and condition 2 as a variable and then assigning false to it. And when Python looks at these variables, it assigns the class Boolean or bool to those two variables. If we cast Boolean true to an integer, we get a 1, and if we cast Boolean false to an integer, we get a 0. So sometimes when we write a if statement, so if we write if like x is equal to 1, then if it becomes true, then this first part of the statement gets executed. If you have an else here, like whenever it's not true, then this part of the statement gets executed. Second, whatever is in the else part gets executed. So this is where we use Boolean fields. So here we can actually say condition 2. Here we already do a condition, and then then we use the condition here, and then we can use that to run through if loops, if or else blocks. So whenever we convert a Boolean true to an integer, it converts it to a 1. Whenever we convert a Boolean false to an integer, it converts to a 0. So when we cast a 0 to a Boolean, similarly, you'll get a false. Or if you do any other number other than 0, if you cast that to a Boolean, you'll get true. Whether it's going to be 1 or 100. I don't know if decimals work too. Let me try that. So any non-zero number that you assign would be true, and when you assign a zero value, it will get casted into a true. Okay, let's look at the next kind of item. So we're looking at assignment. So when we talk about the left part of the equation, that's the variable, and the right part of the equation is called the literal. Literal is a constant or something that we assign into the variable. So if you use the terms literal and variable, these are what they get used as. So the part in the left is a variable, and the part in the right is a literal. So let's go ahead and work on indentation. I think last week I covered this a little bit. So what we do with Python um, is indentation, where we indent the code in this way so that it becomes two things. One is readable, and it looks like consistent with other code. So if you move from one code base to another code base, you move from one company to another company and look at the code, you quickly understand how the code is working. You can write the code like this as well, which is like not indented. You can put in like semicolons, like in other languages, where one line is ended. Say if I want to like rewrite the next statement as well, I can do this and say, okay, do all this, and then it does that. So whenever I want the if case to be true, I just put in the values, and like the next statement is here, and then like this statement is actually similar to this. So I'm and then the next statement is here, print. So we can do all this in one line, but it's very difficult for people to understand what's happening here. um, and this is not a convention that's used everywhere. So rather we indent it this way. So whenever there's an if statement, we go on and end it. We don't use semicolons typically when we code our Python programs. We write each statement in one line, unless we can't cover that in one line, then we cover it in like a couple of lines because the string is too long or something like that. Whenever we have these kind of branching statements, if else, then we indent it, and in a lot of cases we write methods. M1 takes in variable a, and then we write all the method here inside, and then when we finish the method, we go back to the normal indent. When we do class, we do the same thing, and then we do all our stuff. We do what all intended, and then we go back here, and then when we have to call method 1, then we do this. We pass in a, and then we execute it. So all the statements that we have to write, mostly if it's not branching, then it's in the same indent level. If we are writing any definition of methods, if you're writing any class variables, if you're writing any if statements, while statements, all those things, we start indenting it. And in real life, we have a lot of uh, times where we have to indent it back. Where we have multiple like nested if statements, multiple nested if while statements, and method within which we have if statement, within which we have a while statement, and within which we have a for loop. In those cases, uh, we do have to like work on, like when we have for, I in range of 10. So within which we have another if loop. So within which we have another while loop. So this is how happens in real life. Um, so in this case, we keep moving into the um, indentation, so that makes it like work in a way where we have multiple indentations. But if you're not using any blocks where we are branching or looping, or we are defining a method or using a class, all those go in the same level. So if here I'm writing 10 different statements like print, and then I'm assigning something, and then I'm writing another calculation. So all those things go at the same level. Okay, so that's kind of indentation. Um, Assignment number 2 is also a little simple. Um, we'll work on tougher assignments starting like class 4. So first 3 assignments would be pretty simple. So you should be able to do it by going through whatever we went through. If possible, googling a few things, you should be able to do it. Assignment number 2 is write a program to get 3 numbers from the input, and then find the largest of the 3 numbers. So you just have to find which of the 3 is largest and then print that out. And I'm hinting it out that use if statements, but you don't have to. Like, if you know a way of not using if statements, if you can use certain methods that are built in, like you can use those as well. So that's something. And to understand, like, if you have a integer and you want to do some method on it, so if you do this, you can understand what it does. Say for example, you want to find an integer equal to another integer, you can use this function. Or if you want to go ahead and do a module less, then you can use this. If you want, so I mean, let me step back a bit. um, so if I want to know what are the like methods that a string has, then I go ahead and put in the class name of string, and then I type in a dot. That will give me all the methods that are available to use for me as a string. So if you look at this, there is like is upper. You can understand that you can use that to check if a string is in uppercase. There's a join, so you can join multiple strings or string with a list. Um, and there's R split, there's title, there's upper. So if you want to convert a string into an uppercase, then we can call that, and that would return back this. The reason I'm telling you this is, so if you want to find any method that you want to use in int and you are not aware of it, obviously you can Google and go to the Python libraries and find it, or whichever editor you are in, you can go in and put this in, and it will give you all the list of methods that are available listed here, and then you can use one of those methods, and that will help you get to like the solution. So you can try that. That would be one other way to understand what are the methods each class has. So Prem, how did it go until now? Do you understand what basic data types are there? Okay. So like we spoke about integers, we spoke about strings today, we spoke about floating points, we spoke about Boolean, we spoke about certain conversion between some of them, like when you have a string um, and then you want to convert that into an integer because it's actually an integer, you can actually use the int method and then convert. So we spoke about that. Uh, we spoke about like how a float, when we convert that into an int, that loses the decimal points. So those are all the things we learned about today. Um, I'll start a little bit into the next topic we'll start. But until now, like, do you have any questions? Like, will you be able to work on the assignment? No questions? Okay, that's good. So let's start on the next topic, that is lists. Um, so lists uh, are similar to arrays that you have heard of in other programming languages. Um, it's a series of items that are stored together in memory in Python. But it need not be a list of integers, a list of float, a list of strings. We don't have to keep them one type of like classes with variable types within the list. It could start with an integer, go into a float, become a string, then another integer, another string, whatever it is, right? I'm going to use Python 3.8. When I type the list of when I print in the type of A, it identifies this as a list. So this whole thing has been identified by Python as a list. And if you want to get values by reference, that is, you want to find and to note, Python uses the values like this address location would be 0, 1, 2. Like if there are 10 elements, if like A has 10 elements, let's use a easier example where we have 1 to 5, 1, 2, 3, 4, 5. In that case, the address location of 0 would be, the first one would be the address location 0, this would be 1, this would be 2, this would be 3, and this would be 4. So A has address location 0, 1, 2, 3, 4. They don't use the addresses starting in 1. So Python uses the 0 starting position as the address location. So whenever we want to get the first element, we use A of 0. Whenever we want to use the 10th element, we use A of 9. Or if you want to use the nth element, you use A of n minus 1. So in this case, when we do A of 0 and A of 2, Prem, can you tell me which one I will print when I say A of 0? 1. And A of 2? Yeah, so I expect it to print 1 and 3. As you said, Prem, yeah, it does print 1 and 3. And next thing we'll work on is slicing. So when you say slicing, there aren't 7 elements, so let me just do 3. So when we do slicing, it's slightly different. So when it does slicing, it does from inclusively, and when it does to, it does excludes it. What do I mean by that? So when we give print everything from 0 until 3, I use a colon and say starting position 0 from 0th position, or let's use the 2 like we used earlier. So here 0 to 2 would mean it prints everything from 0th position, 1 position, and then 2 position it actually excludes it off. So it only does the 0th position and the first position, which is like numbers 1 and 2. So it just prints those two. That's how the slicing operator works. So when the slicing operator is used, when you put in 0 up to 2, it takes the 0, goes on until 2, but it excludes the 2 and only returns the 0th and 1th position. So that's one way slicing is slightly different. And if for instance I use 0 until 4, that is I want everything except the last element, so I use 0 until 4. I can go ahead and list 1 2 3 4, and if I need everything, I typically say 0 until everything. I don't say any number there, and then that gives me everything. So I don't if I don't specify anything here, I don't know what happens if I specify 5 or 6. Probably it will work, but yeah, it the way slicing works is you the last position is excluded and the first position is included. So that's something you have to remember. So let's take this example 1 to 9. I'm just repeating what I said. So the slice operator returns a part of the string from the nth character to the mth character, um, including the first but excluding the last. There is no index out of range exception for a slice. Slice is actually forgiving. So let me understand. Let me tell you what a index out of range exception is. So here, when we say a is 1 to 9, or let me just take this up. So when we referenced a of 0 and a of 2 above, we got the values 1 and 3. But here, when I'm going to say a of 25, so there aren't 25 elements here. When I ask Python to print a of 25, it's going to say list out of list index out of range, and it throws an index error. And the reason is Python is unable to find the 25th element or the 24 address element. Um, it is unable to find that. So the 26th element. So if I rather say give me everything until the 25th element, then we would avoid that error because Python is forgiving when we actually slice it, so it doesn't throw an error there. This can be used in lots of logic when we actually come to like competitive programming. When you're asked to data structure algorithm programming questions in interviews, this one concept will help you a lot. So when you index this by 25, Python is going to throw an index error. But when we actually use a slicing operator and say 25 onwards, you provide something, which means there is nothing there, we would get a nothing like an empty list. Or if you want to say provide everything until 25, then we provide the whole list because this is a 9-element array. So when it comes to slicing, Python is very forgiving, so it doesn't cause issues when we are when we're using a longer index than needed, or a shorter index than needed. So that's going to be how that works. So we'll use another example of here. I'm going to print something from 0 to 7. So 0th index to 7th index. My array is 1 to 9, and the 0th element is 1, and the 7th element is 6. So Prem, I'm going to ask you again. What do you think this will print? Print a of 0 to 7. So the 0th index has the value 1, and the 7th index has the value 8. So do you know what this will print? Yeah, like this one, we only have the values 1 to 9. Okay, so it will print 1 to 8. It will actually exclude the 8. Uh, Very good. Yeah, I think that's what it will print, 1 to 7. Yeah, so that's what it print. So this is a little confusing because it's counterintuitive. It includes this piece, but it excludes this piece. So the eighth, no, the value 8 is excluded. It doesn't include it. Everything before that gets printed out. So that's good. Let's go into slightly more complex. So in indexing, again, when you go into like if you're going to an interview where they're definitely questioning you on Python, uh, this would definitely come handy. Whether it's going to be a coding interview or if it's going to be a concept wise interview. So another index option you can use is a negative number. A negative number, what it does is it uses the second last position. Hey, are you guys still there? Prem, oh, Prem, you're still there. Yeah, sorry, I just heard a beep. I was not sure if somebody dropped. Okay, okay. So let's go on. I think 20 more minutes of class. Um, I'll keep going on. So when we do a negative number, so when we use a negative number, what it does is it it chooses the second last position, or if it's -1, then it's a first last position, um, and then it uh, moves on until the number we have specified here. So in this case, what I'm doing is I'm starting from negative, let's say 2, which means if you look at this, this is a 1 to 9 array. When I say -2, then it moves from here to here. So the position that we give here is this. It's equivalent to giving 7 here. It's equivalent to giving 0, 1, 2, 3, 4, 5, 6, 7. It's equivalent to giving 7 here. So if I give 7 here and do this, I'll get the same exact result. So instead of giving my -2, if I give 7 here, it will give the same exact result. So let's test it out and see if that theory is right. Uh, so in this case, what's happening is we are moving to the second last position, and then there's no end position, so it prints everything from that starting point onwards. So it goes to the second last position and then prints everything. So if I do the same from the 7th index position onwards until everything, so that provides me a similar result because the index of this is 7 and everything starting from 7 would be just 8 and 9. So negative position like if you give a negative number, if it's a number 3, then it will be the third last position. If I give the number 6, then it will be a sixth last position. And in this case, if we try the sixth last position, so let me try that. If I say sixth last position until the end, that would mean so this is the first last position, second last position, third last position, fourth last position, fifth, sixth. So this would be the fifth last position. So my expectation would be to start at sixth last position. And if I say provide me until the index 7, then that would be the index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7. So and it has to exclude the index 7. So I'm going to say go back. So what that would do is it would print everything until 7. So what it did is it started at the position 4, which is the sixth last position. If you remember, right, 1, 2, 3, 4, 5, 6. The sixth last position is 4, and the seventh index position is actually 8. 1, 2. I mean 0, 1, 2, 3, 4, 5, 6, 7. So the seventh last index position is 8. But because the position that you give in the second place is excluded, it moves down 1 and then it picks everything from 4 until 7. So that's how this works. So let's throw things a little bit off to the side. What if we use the second last position as the like the second position in the slicing operator? So in the slicing operator, we are going to say start at 0. That means start at the very beginning, first index, but go until the second last position. So we're asking it to go until the second last position. In this case, the second last position is 8, and it typically excludes it. That means it goes from here until here, but excludes this. So the starting position is this, the ending position is this, but it excludes it. So I expect it to just print 1 until 7. Let's try that out. And that came out as we expected it. So what it does is it goes to the second last position, exclude that, and then does everything before that it is asked to do. Obviously, this is the same as not even providing a 0. Like when we do this as well, Python always assumes that's a 0 and it pulls in all the values. Another condition where we have both negative numbers on both the sides of the slice. So if I say start at the negative fifth position, that is the fifth last position, which is like this, because like 1, 2, 3, 4, 5. So the fifth last position is 5, and the first last position is this. But because we exclude it, we should get the 5, 6, and 7, and 8. So when we use both negative numbers, both sides we count from the last. So we count the fifth last position and the first last position. And we want everything from the fifth last position until the first last position. The first last position is excluded. So in that case, we are going to get 5, 6, 7, 8. Let's try that out. And that's how it works. What if I'm a bit confused and I use the give me everything from the first last position, that is from 9, until the fifth last position, which doesn't make sense because there's nothing from a later position to a previous position. So what do I do? What if I do that? So that's what I'm going to try here. I'm going to ask it to give me everything from the first last position, which is a later position, to a fifth last position, which is a previous position. So if we try that out, we get an empty array because it doesn't make sense for Python to like find something in between the 9th element and the like 5th element. So it has to be 5th element to 9th element. So it can't start at the 9th element and then go back to the 5th element. So it doesn't it's not able to find something here. So just to ground ourselves back, so if you're not using negative numbers, just use normal numbers. When we use 1 to 5, the first index position would be 2, and then the fifth index position would be a 6. But because we are excluding the sixth position, we'll get only things from the first position until the like the number 5, which is the fourth position. So that will get 2, 3, 4, and 5. And when we print a of 1 to 1, or let's say a of 5 to 5, so whenever we given any value, start at that position and end at the same position, because that position is excluded, we don't actually get any values out returned by Python. That's how lists work and list slicing work. Let's understand a slightly more complex concept about lists. And this might come up handy because there are other things in Python that are mutable versus unmutable. So lists are mutable. What do you mean by mutable? It can be changed. The value can be altered. The elements in the list can be altered. You can add more elements to the list, remove elements from the list, and Python will still have the same memory location, and it will be able to actually change it. But in other cases, like if it's a tuple, those are unmutable. So if you store a tuple in a memory location, if you have to actually change the value, Python lets go of the memory location it currently has, puts in the new value into the tuple, the whole tuple. If it's a tuple has like 10 elements, it puts in the whole tuple in different memory location and loses the memory location from previous one. So that's something. Right now, if you don't completely understand what mutable means and why, uh, like what does it mean by unchangeable, I think what you need to understand is, from a programmer's perspective, you might be able to change the value in a list and be able to change a value in a unmutable element like tuple. You might be able to add values to the list, and also like in a tuple you might be able to make it from a 2 element tuple to a 4 element tuple. But what essentially happens in lists in the background and what essentially happens in an unmutable data element is different. So lists handle it differently in Python, which are mutable, versus unmutable data structures do it differently. So that should be good to move on for now, but we'll get into that the detail on why lists are mutable versus why other data structures are unmutable. And there are a list of there are a set of data types that are mutable and the set of data types that are unmutable, and we use when we have to choose what type of data structure to use, then we'll consider whether it's mutable or not to be able to choose a list in certain cases. And in other cases we'll say, okay, because we want an unmutable element for this, we'll choose this data type. So we'll make a right choice of what data structure to use based on whether it's mutability. So that's something that will come up a little bit later.